The next thing we're going to look at is solving triangles. Now specifically we'll be solving right triangles in this section, and later on we'll solve general triangles. To solve a triangle means to determine the lengths of the sides and the measures of the angles. So what's going to be happening is that you're going to be given, in this case, a right triangle, and you're going to have some information about it. Now the specific information you'll be given will depend on the problem. Sometimes you'll be given two sides, sometimes you're given a side and an angle. You just don't know. So for this case, I'm just going to label this one and this right here. And so from this information, we're supposed to get all the other sides of the triangle. Now for convenience, we tend to use a notation that helps us organize our information. So A is across from the angle alpha, use B across from the angle beta, and C for the hypotenuse. It's not always like this, but being consistent with your labeling will help you avoid mistakes. And so the question is, well, what techniques do we have to use with this? Well, there are two things. First thing is we have the Pythagorean theorem. A squared plus B squared equals C squared, right? The sum of the squares of the lengths of the legs of the triangle, right triangle, is equal to the square of the length of the hypotenuse. So A squared plus B squared equals C squared. This helps you determine the length of the third side if you're only given two of the sides. Otherwise, you're going to have to use the trigonometric relationships. So kata. From this, knowing the sine and cosine functions of various angles, you will be able to determine the other, you'll be able to set up equations that will help you determine the other sides. Now, when you do this, if the angle is a known value from the unit circle diagram, you should use the exact value, meaning you should use the square root of 3 over 2 or the 1/2 or the root 2 over 2. Those values, when you're given the angles of 30 degrees or 60 degrees or 45 degrees, those are the ones that you should be using. You should not be using a calculator for those numbers. If you're given other values like 37 degrees, 15 degrees, 18 degrees, then you can go and use a calculator. It's really important when you use a calculator, make sure you know what mode it's in. Calculators can do your computations in degrees or radians, and you have to make sure you're in the appropriate units for the calculation that you're doing. So please keep an eye on that. So here's an example. Solve this triangle. Now remember, solving a triangle means finding the lengths of all the sides and determining all the angles. Now I'm going to make a little chart here off to the side. We have three angles that we need, and we have three lengths. And it's going to be helpful for us to label this, so I'll label the known side A, B is the other leg, and C is the hypotenuse. Again, keeping consistent with previous notation. And that would make this angle here alpha, this one beta, and that one gamma. So we already know some information. We know A is equal to 6, we know alpha is equal to 30 degrees, and we know gamma is equal to 90 degrees. So the first thing we might want to do here, since we know two of the angles, is determine the third angle. And this comes from the fact that the sum of the angles of the triangle equals 180 degrees. So I'll write it out. Alpha plus beta plus gamma equals 180 degrees. We know alpha, 30 degrees. We know gamma, which is 90 degrees. And so we can plug those in, and if we subtract off 90, we subtract off 30, we get beta is equal to 60 degrees. Now you might have also been able to recognize that this is a 30, 60, 90 triangle just from these two sides, knowing that it's a 30 and 90 there. But this is how we would do it in general, just in case it's not one of those known triangles. So that's the first part of this. We now have all three angles. We need to work on the other two sides now. Let's focus on side C for a moment. So we know that this side has length 6, and we are interested in finding the hypotenuse. And we're going to have to pick one of the trigonometric functions to work with. Focusing on this angle alpha, focusing on this 30-degree angle. What is that side relative to the 30-degree angle? That is the opposite side. This side, C, is the hypotenuse. Opposite hypotenuse. Which trigonometric function relates opposite to hypotenuse? Since it's the sine function, we can take this formula right here and plug things in. So sine of 30 degrees is equal to opposite, which is 6, over the hypotenuse, which we don't know, that's C. From this, we now need to think, well, what is sine of 30 degrees? Sine of 30 degrees, you have to go back and think about the chart of values from the unit circle. Sine of 30 degrees is 1/2. So 1/2 is equal to 6 over C. And if we solve for c, we multiply both sides by c, multiply both sides by 2, we get c is equal to 12. Now, you could have also done this because this is a 30, 60, 90 triangle. You know that the shortest side is half the length of the hypotenuse. That's part of the 30, 60, 90 relationship. But again, we're doing this to sort of set things up in general. So then the last part would be to calculate b. And there are a couple different methods. We can just solve for b using this, a relationship like this. We could use the cosine of alpha. Or maybe even if you want to switch it up, you can use sine of beta. Or you could even use the tangent function. Alternatively, you could use the Pythagorean theorem. A squared plus b squared equals c squared. And so I'm going to stick that right over here. Let me switch sides. So a squared plus b squared equals c squared. Our a is 6. So 6 squared plus b squared is equal to, our c was 12. 6 squared is 36. 12 squared is 144. Subtract off. B squared is 108. So b is equal to the square root of 108. Now this is acceptable as it is. We should check to see whether it reduces. We can see that it's divisible by 9. And so there's at least a factor of 3 that comes out. So let's see. Let's do the calculation here. 108 is 3 times something. 3 times 36. And so we have 36. Oh, well, 36 is already square. So we could just do 6 square root of 3. So square root of 108 is square root of 3 times square root of 36. Square root of 36 is 6. So 6 square root of 3. And so the third side is 6 square root of 3. And again, because it's a 30, 60, 90 triangle, you could have done that by just remembering the ratios between the various sides. But it's important to see the big picture as well. Here's a typical sounding word problem involving solving parts of a triangle. From a point 30 feet from the base of a tree, the angle from the ground to the top of the tree is 57 degrees. Determine the height of the tree. All right, so what's going on? Well, let's draw a little diagram. There's our tree. We are at a point 30 feet from the base of the tree. So 30 feet this way. So we're 30 feet away from the tree. The angle from the ground to the top of the tree is 57 degrees. Determine the height of the tree. So we'll label the height of the tree h. That's our variable that we're trying to determine. So we don't need all the parts of the triangle in this case. We just need h. And so what do we think about? Well, we have an angle. We have this side and that side. We have the opposite and the adjacent side. Which trigonometric function relates an angle to the opposite and adjacent sides? So you think through SOHCAHTOA, and you should end up with the tangent of theta is the opposite over adjacent. And so all we need to do is take these values and plug it in. Tangent of 57 degrees is equal to the opposite, which is the h, over the adjacent, which is 30. Now, I would push back against plugging this into the calculator right away. Sometimes when students do that, you start to introduce rounding errors, and then especially if the problem's longer, those errors propagate forward and make your final answer less accurate. So it's best, I think, to keep this in its exact form until you need to plug it into a calculator. So let's go ahead and leave it like this. We want to solve for h. We're going to multiply both sides by 30. So h is equal to 30 times tangent of 57 degrees. Now, this is an exact value for h. Just like when we were working with the pi values when we were talking about circles, in a practical situation, this is not helpful. This does not actually tell someone how tall the tree actually is. And so this is where you then go to your calculator and plug it in. Very important, when you do this, make sure your calculator is in degree mode because we're working in degrees and not radians. This is just something you have to check. It's just be diligent about it. When you plug this into a calculator, you're going to get that this is about 46.2 feet. Right? And of course, this number 46.2 is way easier to understand than 30 times tangent 57 degrees. So this is how we solve this problem. We actually have determined the height of the tree based on how far away we are from the base and the angle up to the top of the tree, and it comes out of the SOHCAHTOA relationships.